Hello, my name is Kira Thompson and I will be discussing the impacts of terrestrial runoff on the presence of bleaching and macroalgae growth on coral reefs in Maunalua Bay. The main character in this project is coral and coral reefs. Coral reefs are one of the most productive and vital ecosystems in the ocean. They provide shelter, food, and protection to a diverse amount of life. Coral is not only important to the ocean, but they are important to us on land as well. Corals are animals themselves, living in a symbiotic relationship with algae called zooxanthellae that give the corals their color. Unfortunately, reefs are under an immense amount of threats, both natural and human-induced. These natural threats include rising sea level, increasing ocean temperatures, and acidification. The increased water temperatures create a major threat called coral bleaching, where the stress causes the corals to expel their zooxanthellae and potentially die. Anthropogenic impacts include unsustainable and destructive fishing practices, pollution, and the one that we are focusing on today is sedimentation, which is the outcome from urban development of coastlines causing erosion of new sediments into the ocean. This can damage reefs in simple ways like suffocation, but even more complicated ways like macroalgae growth and phase shifting. The location for this study is Maunalua Bay, which is on the southeast side of Oahu. It is the perfect project site as it is a heavily developed coastal area that has many reefs that are facing the impacts of sedimentation, yet lacks the research on this study. There are many watersheds that pour into the bay, contributing to the runoff, and it was labeled as an impaired body of water in 2009. The reefs that will be the study sites are Point Panic and Fantasy Reef inside the bay, and Turtle Canyons, which is located outside of Kewalo Basin Harbor, which is adjacent to the bay. The partner for this project is Ocean Alliance Projects. Based on Oahu, they are an ecological monitoring program that is a nonprofit organization. Their mission is to protect and preserve marine biodiversity. They work with many other organizations in Hawaii teaching the public how to monitor the reefs in Maunalua Bay for things like bleaching, coral disease, and coral growth. I have worked with them to get the data they collected from the reefs for this project. Their work will make the difference to create change in the future with long-term data analyzation and monitoring of the reefs in Maunalua Bay. The main goal and purpose of this project is to identify the impacts of the terrestrial runoff that it is having on the reefs in Maunalua Bay, focusing on the macroalgae growth and the bleaching susceptibility. The benefits to the community will be the ability to use this newly found evidence to create potential solutions for better policy and management of land resources. For example, trying to better manage the coastal erosion from beaches or housing development. This data will also contribute to long-term studies for policy changes on the ecosystem. The methods used for this project were coral reef transects, specifically waypoint transects. This type of transect method uses a GPS coordinate instead of a physical line in the water to follow due to the strong current and wave action in this area. These transects had pictures taken every 6 seconds for a total of 100 images per transect. They were analyzed using point count analysis on a software called CoralNet, which places 10 randomized points on the images, and then the substrate was identified under those points. This data was then organized into Excel, and coral cover abundances by substrate type was calculated. Statistical analysis was done using RStudio, and this was done with linear regression to analyze the relationship between sedimentation, macroalgae growth, and coral bleaching. To estimate sedimentation in the water, daily precipitation was used instead since runoff was not directly measured during the study. This figure gives the daily precipitation rate during the days of transect collection. The highest was in mid-March 2023 and the lowest was November 2022 and January 2023. The coral cover for Fantasy Reef had 0 bleached coral in November of 2022 and a high percentage of macroalgae growth in both November 2022 and March 2023. In March, there was minimal percentage of bleached coral. Point Panic had similar values in both bleached coral and macroalgae growth in November 2022, but had a spike in macroalgae growth compared to bleached coral in January 2023. Turtle Canyons had a high abundance of macroalgae growth and a low abundance of bleached coral in the overall coral coverage. Using linear regression to see the relationship between the percentage of coral bleached and the macroalgae growth percentage, there was a trend discovered in all 3 reefs, where the less percentage of macroalgae, there was a higher percentage of bleached coral looking at it per transect. Although they all also had one outlier where there was a higher abundance of macroalgae growth, they also had a high abundance of bleached coral. To explain the results in more detail, Fantasy Reef ended up with the highest overall macroalgae growth and the lowest percentage of bleached coral. This reef also contained the highest amount of precipitation, which for the study meant the most amount of sedimentation. These results gave some insight about the reasoning of less bleaching occurring due to the blanketing effects that the sediments and heavy macroalgae growth gave to the coral reef. Unfortunately, this reef ended up with an insignificant p-value, which could be due to the small sample size of the transect images from this reef. On average, there was only approximately 50 images from each transect on this reef, whereas there was supposed to be double that amount. This was just one side effect of having citizen scientists as a part of this project. Point Panic had the highest percentage of bleached coral and the second greatest abundance of macroalgae growth among the reef with 0 inches of precipitation. This doesn't mean that there is 0 sediments in the water, but that there is minimal runoff going into the water during this time. This lack of sedimentation could help prove the fact that the bleaching would be the driving factor for the macroalgae growth and could be signs of a phase-shifting reef. Since the p-value for this data was also insignificant, the hypothesis cannot fully be accepted, but this could be due to a type 2 error of the data being very similar between the macroalgae growth and the bleaching percentages. Turtle Canyons sat in between the two for macroalgae growth, bleaching, and sedimentation. Since this reef had significantly less sedimentation than Fantasy Reef, this could allow for more surface area of the corals to be exposed to the elements for bleaching and could explain why there was more bleaching on this reef than Fantasy Reef. This data had showed statistical significance with its p-value. Other factors that could be contributing to the alterations in this data could be the seasonal fluctuations in the precipitation, which impacts the amount of runoff going into the water. Due to the seasonal changes, the runoff is not consistent over time and can have potential delayed effects. Location of the reefs themselves can also have an impact. Point Panic is a more shallow reef with corals at depths of 20 feet in some areas, and this reef is the one with the most bleached corals. Depending on the depth, it can also affect the growth of algae or the vulnerability to bleaching. This also brings up the point of the species of the corals making up the reefs, as certain corals have higher susceptibilities to bleaching or are a more robust coral to disturbances. Point Panic had mostly Matipora capitata, which is a high bleaching coral, while Fantasy and Turtles had more Parietes lobata, which are more robust. Coral reef diversity will also create high resilience and alter the data. Point Panic had a more even spread across different species, while Fantasy and Turtles were less diverse in their species. While this study was informative, Further research could be done where each variable could be isolated individually to see how each one is being affected. Since all of these factors seem to be interacting so closely, it would give more insight to test them separately. This research was also limited by its time constraint over a short 5-month period. Conducting a similar study over a longer period of time would allow for more data collection and could show better trends. Focusing on the coral species and their responses to the factors by conducting a study specifically on the coral species would also contribute good data to the overall ecosystem and solution. Through all of these further research projects, collaborating with other entities would be beneficial as it would give more resources as well as more minds working together to come up with solutions on the issue. In conclusion, studying this relationship between sedimentation, macroalgae growth, and bleaching is becoming more relevant and important. This research adds to a growing body of research on the impact anthropogenic issues such as runoff and sedimentation has on coral reefs. Through ecological monitoring, we can continue to keep track of progress and changes to create better environmental and land management policies. Thank you for taking the time to listen to my presentation today.